Hi folks, I'm Olga. Welcome to the episode 5 of my online course in basic statistics. In this episode I'll talk about normal, standard normal and t-distributions. So let's start with a very quick recap. In episode 1 I explained how to build histogram and how from the histogram we can derive the distribution. Get back to that episode for full details if you need, but here is a small example that will serve as a recap in this episode to us. So we have some data about the exam results for 100 students, and we built a histogram for this data. On the horizontal axis you can see scores in percentage. On the vertical axis are frequencies. Just a remark, frequencies here are not what we call height in episode 1, but it doesn't matter because all bars are 5 points wide, so dividing by 5 will simply rescale and will have no real influence on how this picture looks. So we see that 3 persons scored around 60 points, 10 persons scored around 65, and so on. Mean for this data is 80, so are the mode and the median. If this data has a bell-shaped histogram and all 3 central measures are equal, we can say that it's normally distributed. Many things are normally distributed. Time for corn to become a popcorn in the microwave is normally distributed. You start heating your popcorn. First you hear one or a couple of kernels puffing up, then process is speeding up till it reaches some peak of popping, then it slows down, and finally only few marginal unpopped corns will expose. So I don't want to spend time on more examples. You can Google them yourself, but I bet you will be surprised how many things actually follow normal distribution in real life, or at least approach normal distribution. So now, why normal distribution is so important and so well known? That's because it has some very handy properties. The area between the curve and the horizontal axis is exactly 1 or 100%, and the area is also infinitely wide since curve never actually touches the axis. In the center of the on the horizontal line is mean, denoted by letter mu, and it also corresponds to the highest point on the normal curve. We know that highest point here shows also the most frequent value, or the mode. So mean would be equal to the mode. Mean can have any numerical value, positive or negative or 0, so we don't have any numerical values now on our horizontal axis, but we suppose that there can be any numerical value. And we see that the normal distribution is symmetric around its mean. So if it's symmetric, it would also mean that the mean is the median. So 50% of values will be to the right, and 50% of the values would be to the left. Standard deviation determines how flat and wide the curve is. Sigma denotes standard deviation, sigma letter, And generally normal distribution is differentiated by two things: its mean and its standard deviation. What does it mean? That you can draw a normal distribution if you know its mean and standard deviation. That there are two things you need to know in order to define a normal distribution. And now we are very close to the most important moment. So why normal distribution is so widely used, so cool, everybody in statistics is supposed to know it. And that's because we always know the percentage of values that are in certain areas. So for example, 68% of all values of the variable, if the variable is random and normally distributed, will be within one standard deviation from the mean. So dark blue area in the center is 68% of total 100% area, and it's calculated as a sum of two 34.1 areas from minus one standard deviation, so to the left from the mean, to plus one standard deviation to the right from the mean. And if we extend and add one more standard deviation to each side, we will accommodate 95.4% of all values. And then within plus minus 3 standard deviation from the mean, almost all values will be, so 99.7%. That's of course ideal model, but as I told you previously, many sets of variables will generate histograms that very closely approximate the shape of normal curve. Okay, so let's get back to our example with grades. What if I want to know how far from the average student is the guy who answered to 90% of questions correctly and got 90? The obvious answer is that this guy is 10 points above. But is it only 10 points above, or wow, as many as 10 points above? To answer this last question, we should kind of weight this 10 points somehow, and we will weight it in terms of standard deviation. So you see on your screen that standard deviation for this data is slightly about 10. So we basically can say that 90 points grade is one standard deviation above the mean. And if we recalculate the distances from the mean in standard deviations for all values or for all students, what we will do standardization of our values, and that's how we will derive to a standard normal distribution. Areas under the curve will stay the same, so 68% of values will still be within plus minus 1 standard deviation from the mean, but our horizontal axis will have a different scale now, with z-scores marked there. So we see that it's minus 1, 1, minus 2, 2, but those are basically our standard deviation. We just don't put sigma there, otherwise it's very similar to what we used to have when we had just simple normal distribution. Finally, a very brief introduction to the t-distribution. So you have to understand one very central idea. In many cases, we don't have the information about the population or about every unit or every person or every firm we're interested to study. We only have some sample, and depending on how big the sample is, the quality of our predictions about the population may differ. So t-distribution is used to take into account our sample size when we make conclusions about the population. So the bigger sample size is, of course, better. So bigger sample size means that t-distribution will be closer to the normal distribution. Okay, in this episode we looked at the normal, standard normal and t-distributions. I will make a small complementary to this episode video on how to read z-table and t-table. And in the next episodes we will talk about sample and population, sampling procedure, sampling distribution, central limit theorem and the law of large numbers. Thanks for watching and good luck with your study in statistics.